Hi everyone. In this video I'm going to go over Tuesday's page in the week 32 packet. So for the do now, which force is responsible for producing a stable nucleus by opposing the electrostatic force of repulsion between protons? You're looking at the notes from yesterday to see which one of those four fundamental forces matches this description. You can pause here to take a look. And the answer is the strong nuclear force. That's what holds the nucleus together by opposing that repulsion that we would expect from the protons. So sometimes it's just called the strong force, so it's choice 1. So today you're filling in another chart. It's a little bit different from the one that you did yesterday. In this chart, you're given the quarks for the most part, and you're calculating the charge and then kind of just checking which of these boxes applies to the description. So U, U, D means up, up, down. So I have 2 up quarks and 1 down quark, which means I have 2 positive 2/3 and 1 negative 1/3. You can just put this into your calculator. You should get positive 1 or just 1. And so I'm going to write positive 1e as my charge. The next step is to kind of see if it's a baryon, if it's a meson, if it's a hadron, and if it's a lepton. And whichever one, or if there's more than one that apply, you'll just put a check mark. So it's made of 3 quarks, so I can check here. I see that 3 quarks is considered a baryon, which is also considered a hadron, because a baryon is a specific type of hadron. So I have my 2 check marks here, and I know that it's not a meson because a meson is composed of 1 quark and 1 antiquark. I know it's not a lepton because there are only 6 possible leptons, and they're all shown right here. Alright, the next one is C with a line over it, S. You might remember yesterday that all of the antiparticles had little lines over them. So C with a line on top of it means anti-charm, and then S means strange. That means I'm going to be taking my charge for the charm quark and just flipping it. So positive 2/3 becomes negative 2/3. And strange is just a regular strange quark, so I have negative 1/3. You can put that in your calculator, and that should give you negative 1. So my charge is negative 1e. Now I want to look up which of these particles I can consider this anti-charm strange quark. So I have 1 quark and 1 antiquark, so it's a meson, which means it's also a hadron. And it's not going to be a lepton again or a baryon for the same reason as last time. These are my only options for leptons. Like anything that's not explicitly an electron, a muon, a tau. One of these 6, it's not considered a lepton. And of course it's not a baryon because it's not made of 3 quarks. The other 2 that I want to go over with you are positron and antiproton, because they actually don't fall into any of these categories. A positron is an antiparticle, so it's not technically a baryon, meson, hadron, or a lepton. The closest it comes to is a lepton, because we see that an electron is a lepton. So an anti-electron is not actually a lepton, it's an anti-lepton. So for these, you're not going to be checking any of these boxes. Same with antiproton. A proton is considered a baryon, so an antiproton is technically an antibaryon. So again, you don't really check any of these boxes for those 2. So you're responsible for filling in the rest of this chart, answering the multiple choice questions, and the exit ticket is true or false. If you have extra time, you can work on the extension.